Thank you all very much. Again, my name is Harveson. I'm director of the Borderlands Research Institute and associate provost of research and development. And on behalf of Sul Ross State University, thank you for being here. We've come a long way in a short amount of time, and obviously this event itself requires a lot of help. There's a lot of busy bees out here working, and we also have, of course, our great sponsors that helped us financially with this program and making sure that we were able to do the content that we were hoping to do. And then we also have a lot of friends, a lot of organizing partners shown here on the screen that help develop the program, help recruit speakers, and so on. So please let's give them a round of applause real quick. So I'm curious, how many of y'all were here 2 years ago when we started this? Okay, so y'all remember that we made a promise. When we had our Water in the Desert conference in 2024, we made a promise to the community, to our stakeholders, to our students, to our funders, that we would do something special. And over the last 2 years, we've been really working hard. We developed a steering committee to help develop a concept of a water center at the time. It is a water institute now. Some really key players, and really these are the ones that actually helped pull the Water and Desert 2024 off. But they're water professionals, they're academics. They put in a tremendous amount of work over the last 2 years, and obviously with some funders. And so we took some concepts and ideas to these funders, and they believed in our vision, a shared vision, again, across stakeholders in the university. And so we really are really thankful to obviously the Horizon, Meadows, Stillwater, Shields Heirs, and the Davidson Foundation. Over those 2 years, we have developed a strategic plan, and you see our mission here to advance the collaborative water solutions in far west Texas through applied research, education, and technical expertise to ensure a resilient water future for the people, land, and wildlife. And so you're going to start seeing a lot more out of our new institute that officially is called the Meadows Research Institute for West Texas Water. It launched January 1st of this year. That is made in part by a gift from our friends with the Meadows Foundation. They've endowed that at a tune of $2.5 million, and also some additional funding for operational support. But we're real. It's happening. You'll see a variety of people. Thank you. And really the ones that have been doing the work for this conference. This is really their launch, right? Is the launch of the Institute is Water and Desert 2.0 or 2026. You'll see here the science and administration team. They literally just got their new shirts today. And so we've got Billy Tarrant, raise your hand, Billy, Dr. Kevin Urbanzik, Kelby DeLon, and Jesse over here. So that is our science and administrative team. And they're going to take that strategic plan and that vision that really all of y'all helped us develop into the future, and to make sure that we are meeting our mission, and to make sure that our West Texas does have water for the future, and making sure we have water security through that time. So we're really excited. Again, extremely thankful to the Meadows Foundation. Lizette is here somewhere. She's hiding, maybe. There she is. Thank you, Lizette. And we'll have Eric Meadows tomorrow on the program. Eric is the president of the Meadows Foundation, and he'll say some words too. But it's been quite a journey. It's been a lot of hard work, but it's been extremely rewarding, and we're really excited about getting this thing off. So you saw a URL. You saw we'll have social media coming soon. We're going to bombard you with information coming out of the Institute, and just making sure that everybody is aware of the great work that team is doing. And so with that, I'd like to introduce our first speaker. And honestly, I don't need a bio. I went to school with this guy. Dr. Roel Lopez. Roel is a dear friend of mine. He was advisor to my wife. He is director of the Natural Resource Institute at Texas A&M. And he's also department head of the, y'all have changed names a couple times, Rangeland Wildlife and Fisheries Management Program at Texas A&M. He did his thesis work on turkeys, his PhD work on key deer. He's a pragmaticist. I mean, he's a scientist, but he's a practical guy, and he does incredible work running both the institute and the department. His interface and really one of the coolest programs that he oversees is land trends. And so when we think about the Trans-Pecos and what the future of the Trans-Pecos looks like, people are a major driver. People affect land use. And then we'll talk about climate also. So those are some of the major drivers. So please welcome to the stage a good friend of mine, Dr. Roel Lopez.
Thank you, and howdy. Oh, we can do better than that. We're starting off a really important conference. Howdy. Thank you. All right, we'll get started. So I was told to kind of set the stage with some land trends related to the Trans-Pecos. Don't have a lot of time. They said you can only do 2 slides, and so Dr. Harveson didn't realize I could put 5 slides on 1 slide, and so this is not my normal slide, but I'm going to give you a real quick overview of where we are in the Trans-Pecos and really give John a little bit more time from a climate perspective, just because of the influence that has from a water piece. The other little side note I would add, Alpine, Texas is near and dear to my heart. So in addition to the relationship with Lewis Harveson, both Lewis and Patricia are my daughter's godparents. And so my daughter was baptized in Alpine, Texas. Little known fact. All right, so here's the scenario. And many of you have heard me say this before. You know, we're seeing changes in working lands, in farms, ranches, family forests across the state. And I think it's a fair statement to start by saying the Trans-Pecos is different. It's real different from a fragmentation, from a conversion, from a land use perspective. So when you look at what's happening statewide, we're losing working lands at a rate of about 1,000 acres a day. 20 years ago, we were losing maybe about 60 acres a day, so it's exponential. And there's a lot of reasons for that. Early predictors are more people, strong economy, and that drives fragmentation or conversion. And so that's a significant challenge. Now, when you look at the Trans-Pecos, and I'm going to give you some basic statistics at a statewide level, but then compare it to the Trans-Pecos, you know, when there's 250,000 landowners in Texas, about 60% of those landowners own less than 100 acres. So that's a growing majority. 5 years ago, we had 40%, now 60%. We're seeing an uptick in the number of small acres landowners. Compare that to the Trans-Pecos, it's actually the opposite. So the largest majority landowner owns 2,000 plus acres. And in fact, I was talking to Robert Potts before the break. This is probably the only place in Texas where we're actually seeing consolidation, aggregation. And so from that perspective, the Trans-Pecos is very different in that way. When you look at the number of acres, again, statewide, not surprising, 70% of 140 million acres are working lands. 140 million out of 171 million acres, that's the size of Texas. About 83% are farms, ranches, family forests. Across the state, 70% are 2,000 acres plus. In the Trans-Pecos, it's about 92%. So again, big lands, big properties, and tremendous opportunities from a conservation perspective. Some of the trends that we see statewide as well as here in the Trans-Pecos is a growing trend and shift toward managing for wildlife, 1D, 1D1 lands. And so that's also true in the Trans-Pecos, seeing about a 20% increase. So the other aspect from a renewable energy, and I pulled these numbers just to share with you, and kind of the maps that show those differences. The little blue dots are turbines, the little orange circles are solar farms. And what we've seen is an increase in turbines of about 61%. So we probably, this is 10 years ago, had about, about 700 turbines in the Trans-Pecos, and we've doubled that in the last 10 years. Solar has been an increase of about 174%. Percentage is always misleading, but there were 2 solar farms 10 years ago. Now we have 33. And so again, these are pretty significant changes with regards to land uses in this part of the world, and they're different. So I can't emphasize that piece. The Trans-Pecos really is different from that perspective, and I think the effort for the Institute and this conference is right on, because water and maintaining that land infrastructure is going to be the key to a sustainable future for this part of the world. So with that, I think that is my time. That's pretty short. Unusual.
I didn't tell him 2 slides, just for the record. So, all right, our next speaker is very well known in the climate world. His name is John Nielsen-Gammon. Dr. Gammon is a Regent Professor of the Department of Atmospheric Sciences at Texas A&M, the Texas State Climatologist, and Director of the Southern Regional Climate Center. He holds 3 degrees from Massachusetts Institute of Technology and is a Fellow of the American Meteorological Society and the American Association for the Advancement of Science. He is a faculty member at Texas A&M and has been there since 1991 and has served as a Texas State climatologist since 2000. He has written or co-written 75 peer-reviewed articles, 13 book chapters, and is editor of the Journal of Applied Meteorology and Climatology. His recent research activities have focused on extreme weather in Texas and the relationship to climate change. Please welcome Dr. Gammon.
Well, I would thank you for that introduction, but you took up time for 2 of my slides already. So fortunately, you didn't tell me I only had 2, so there's still some room in here. And what I want to focus on is the danger of looking at trends and extrapolating. It's tempting to interpret any trend in the water system as being related to climate change, since that's been in the news a lot, but generally speaking, there's a lot of other factors. Roel mentioned a lot of factors that affect surface water and groundwater. There are others that are going to be spoken of in this conference. Climate change also affect those to some extent. As you go farther up to the rain and the temperature, the human impacts locally become less important, but the larger scale climate change impacts matter too. But not every trend is climate change, even in the atmosphere. And it's tricky to sort that out. And just to give you one example, here are 2 different takes on the trends of extreme cold in Texas. What's plotted is for the past 130 years or so, the coldest temperature averaged across the state in each winter. And on the left, you can see there's a pretty strong upward trend. On the right, there's a recent downward trend. The difference between these 2 data sets is the data is exactly the same. Every single dot is the same. The only thing I've changed is how much I smooth the curve. So if you're looking just at the past 10, 20 years, 30 years even, it's getting colder. If you look at the perspective of 50 or 60 years or 100 years, it's getting warmer. And you have to treat local trends, particularly with a grain of salt, because variability in the climate matters a great deal. So that's the meaning of my title. There's a difference between saying there is a trend, which implies something about the future, and that there's been a trend, which is focused mainly on the past. So let's look at a couple trends. First off, average temperature in Texas. On the left is the trend over the past 130 years, and the right is the trend in the past 50 or 60 years. And past 50 or 60 years, the trend is much stronger. It's about 1/2 to 3/4 of a degree per decade, which translates into about 3 degrees over this period. Now, which trend is more important or relevant to looking for the future? It turns out the trend on the right is, because if we look at the global temperature trend, it sort of follows the same basic pattern. There wasn't much climate change until the 1960s, 1970s. Since then, it's been increasing almost as a straight line. So looking at the local trend over that same period probably gives a good indication of what's been happening because of the global trend in temperatures. So that's why focusing on that interval of time is useful. Precipitation is dominated a lot more by natural variability, so it gets tricky. Here's the same pair of slides, now we're looking at the precipitation trend as in terms of percent change per decade. And on the left, we've got the past 130 years, which has an upward trend in central and eastern Texas, and a downward trend in West Texas, including the Trans-Pecos region. But the downward trend is only about 0.5% per decade, so not really noticeable. But if you want noticeable, you got the right-hand side, which shows the past 55 years or so, and the trend is more like negative 5% per decade, extended over a 50-year period. It's a very dramatic drying trend. So which of these is more relevant for looking at the future? Well, to sort this out, at least in terms of the observations, let's look at the time series of precipitation averaged over the Trans-Pecos, looking at annual rainfall from 1895 to the present. You see it's got a lot of ups and downs in it. 1941 was quite a wet year. I don't see anybody who looks like they were here in 1941, so much younger crowd than that. But the driest was 2011, which a lot of you will remember. Now the trend for the past 55 years, if we overlay it, strong downward trend as you saw on the map, but it's sort of a fake trend in the sense of you weren't really expecting 15 inches of rain back in the 1970s. That happened to be a relatively wet period historically, and so focusing on that period sort of exaggerates the trend. But indeed, it has been getting drier in recent years. If we look at the periods of time, say from the mid-1970s to early 1990s, most years were wet years. Then we went through a period of about a decade around the turn of the millennium where most years were dry years. And then it's been flipping back and forth since then. The most recent 6 years, 1 year was near normal or meh, the other 5 were clearly dry. And that clearly explains the drought that we've been experiencing here. But on the long time scale, the conditions over the past 2 or 3 decades are not much different from the conditions back in the early part of the 20th century. So at least from this graph, it looks like more like we're a little bit below what the long-term historical is rather than being a part of a ongoing long-term drying trend. And climate models sort of predict the same thing. They're not very good at pinning down precipitation changes, but the climate models at least are saying that the change over several decades, the next few decades, is projected to be less than 5% decrease. And that's not necessarily on top of the decrease we've already seen. That's on top of what would have been expected without the ups and downs that have been experienced. So bottom line here is temperatures are definitely increasing and be expected to continue increasing. Rainfall has decreased, but it's not clear at all whether that trend is going to continue. In fact, it may recover in the next decade or two, but probably not to the levels we saw in the 1970s and 1980s. So the new normal is probably wetter than this drought that we're experiencing, but unfortunately it'll be at least as hot, and the high temperatures mean that whatever rainfall falls is lost more quickly through evaporation. So in terms of drought going forward, we're looking not necessarily at more droughts, but at hotter droughts. Thank you.
Climate, population pressure, and land use change. What can we slow down of those? What do we do? I live in the desert. I've been here 28 years. What do we need to be doing? What does the Meadows Research Institute need to be doing to deal with population pressures and land use changes, even though I think we're an anomaly, but you know that's not going to hold up, in my opinion. And then I guess for you, John, is the same thing on the climate. What can we do? So maybe Roel, maybe take that first.
Yeah, so can you hear me okay? So let me start by the fragmentation or conversion here is different. One thing I didn't mention, the fragmentation that we see in this part of the world is also different in the sense that you may have a large tract that's platted for a subdivision, but it never materializes when people realize there's no power, there's no water. And so there's a lot of that. It's kind of an interesting thing to see, and you see a lot of it here. But the type of development and driver, so this is my opinion, that's tied to renewables and traditional oil and gas is probably not going to draw the same human footprint that you're going to see. So I think the pressure you're going to see from a land use conversion perspective is going to be tied to energy, and that's probably going to be limited compared to other parts of the state, in my opinion. The climate piece is more challenging. I'll let John kind of give his perspective.
Yeah, we can't really do much about the climate locally. In some places, land use changes have a big effect on local climate, such as with urban heat islands, but we're a long ways from that in the Trans-Pecos region. But what you do have to deal with locally is adaptation, understanding what the ecosystem supports, what working lands can support in a changing climate. And you can get a first handle on that by essentially looking at the variations with altitude, because a warmer climate is equivalent to essentially lowering the land by 100 or 200 feet and changing the altitude. You can see how much the ecosystems vary by altitude and how much the productivity varies by altitude and so forth. But working out the details of that and what practical solutions are is an excellent task for the new Meadows Center.
So I want to just add a quick comment. So I come out here fairly often, I guess, or every so often. And a lot of times when I'm coming out here, I'll call Dr. Harveson and I tell him this, and this goes to the question of land use, land conversion. I said, this West Texas thing would be so much nicer if it was outside of Bernie, you know? And the response always is, that's precisely why we're here. And so I think the distance works from a traditional land use, land fragmentation. I just don't see the boom that we see in other parts of the state. It's just not, in my opinion. So.
All right, do we have some questions from the audience?
Go ahead.
Basically say you got to have the water first before you can build.
Yeah, but and there's people in the audience that would be better suited to answer that question. So I can, typically there's governing structures for that and so forth. So I assume, and I'm going to look at my water friends here, you'd have to work through the county and get permissions. That's where those subdivisions fail. They go out, they have this dream, they're going to subdivide, and then they realize they can't pull a permit for water wells or some sort of water source, and so then they die. So that's typically what happens in and around the state.
Yes, sir.
Thanks very much. And I think you were relationship to your research to aquifers and water.
I don't directly work with aquifers, but I've focused on drought and projections of drought. One thing that climate models are pretty much unanimous about, only behind temperature change, is a decrease in soil moisture. Water doesn't stay in the soil as long, it evaporates more rapidly. And if you're losing water off the top of the soil layer, that means you're not getting as much water down through the bottom, producing infiltration. So the expectation would be a reduction in the recharge of aquifers. At the same time, if aquifers are being utilized for agriculture or other purposes, plants are going to tend to demand more water in a warmer climate, so that you're losing more water through use of aquifers at the same time. So the pressure is on them at both sides, but the details of how big that pressure is matters quite a bit from individual aquifer to aquifer.
So from an NRI perspective, we don't do a lot of work specifically with aquifers, but I'm staying at a Holiday Inn tonight. So to me, that there's entities to include this new institute that would do a better job at that. So we tend to partner quite a bit, actually. So I don't know if Robert Mace is here. So Robert and I work on different projects as well. At A&M, we've got the Texas Water Resources Institute. And so we tend to partner with folks that are really more grounded, no pun intended, in water, and so what we bring to the table is how changes in watersheds and landscapes can impact that from a water quality perspective, from a water abundance, et cetera. And I think we may be out of time, so that's kind of where we focus our efforts on.
All right, one more question. Yes, sir.
Well, it may be better to ask this one later, but 2 years ago, the rule of law, or rule of capture came up in discussions, and you've seen any change over 2 years in the current rule of law? Rule of capture.
I hate to kick this down the road, but tomorrow, we have a titillating conversation about the rule of capture, and so let's make sure we address that tomorrow, if you don't mind. Okay, we are out of time for questions right now. Let's thank our panelists, and then we're going to ask them to step off to the right.